morning, Puan Haizam and my fellow friends. Today, I, Logeswari, Mishalini, Juanesan, and Idfariat will be presenting regarding the question given. So, I'll be presenting question 1. Okay. Question 1 is based on figure 1, generate the segment table for the segments given. So the technique that I used to solve this question was, okay, I subtract 978 with 740, so the remaining was 238. Then I subtract 1528 with 1200, so the balance was 328. Then lastly, I subtract 5500 with 3200, and the remaining was 2300. So in order to generate a segment table, we have to subtract a segment with the other programs. So we get the limit to generate a segment table. So the segmentation, let us see the segmentation table. So the limit for segmentation 1 was 238 and the base was 740. Second, the second segmentation was segmentation 2 and the limit was 2300 and the base was 3200. Lastly, segmentation 2, the limit was 328 and the base was 1200. So thank you.
Okay, I'm Ifa. Want to present question 2. Question 2, table 1 show the process with their burst time and arrival time. Process 0 is burst time 5 to arrival time 0. Process 1 is burst time 3 and arrival time 1. Process 2 is burst time is 8 and arrival time 2. Process 3 burst time is 6 and arrival time 3. First in, first out. Scheduling algorithm. Solve the problem for question 2A by refer table 1. This is the Gantt chart. And calculate the average turnaround time is 11.25 millisecond. TAT ET minus BT 80. Process 0 is 5 millisecond minus 0 equal to 5 millisecond. Process 1, 8 millisecond minus 1 equal to 3 millisecond. Process 2, berapa ni? 16 millisecond minus 2 equal to 14 millisecond. Process 3, 22 millisecond minus 5 to equal 40 millisecond. And average all 5 plus 7 plus 14 plus 19 divided by 4 and equal to 11.25 millisecond. Average waiting time 5.25 millisecond. Formula for waiting time is TAT minus BT equal divide EQT. Process 0, 5 millisecond minus 5 equal to 0 millisecond. Process 1, 7 millisecond minus 3 equal to 4 millisecond. Process 2, 40 millisecond minus 8 equal to 6 millisecond. Process 3, 40 millisecond minus 6 equal to 30 millisecond. The response time is formula time start on Gantt chart. minus arrival time. Process, wait. Process 0 millisecond minus 0 equal to 0 millisecond. Process 1 is 5 millisecond minus 1 equal to 4 millisecond. Process 2, 8 millisecond minus 2 equal to 6 millisecond. Process 3, 60 millisecond minus 3 equal to 30 millisecond.
Okay, hi, Jonathan. Followed by question 2, we go for question B. Shortest job first, SJF. So first of all, move for Gantt chart. So process 0 start from 0 and end at 5 millisecond. Process 1 start at 5 millisecond and end at 8 millisecond. Process 3 start at 8 millisecond and end at 14 millisecond, and process 2 start at 14 millisecond and at 22 milliseconds. So move to question B1. Average turnaround time is 10.75 milliseconds. For the formula, average turnaround time is ET minus AT. So process 0, 5 millisecond minus 0 is equal to 5 milliseconds. Process 1, 8 millisecond minus by 1 is equal to 7 milliseconds. Process 2 minus by 22 millisecond minus by 20 is equal to 20 milliseconds. And process 3, 14 millisecond minus by 3 and is equal to 11 milliseconds. For the average, we have to total all the answers divided by 4 is equal to 10.75 milliseconds. So move to average time waiting. His answer is 5.25 milliseconds. So process 1, 5 milliseconds minus by 5 is equal to 0 milliseconds. Process 1 is 7 milliseconds minus by 3 and is equal to 4 milliseconds. Process 2, 20 millisecond minus by 8 and is equal to 12 millisecond. And process 3, 11 millisecond minus by 6 is equal to 5 milliseconds. So after average, we have total all the answers and divided by 4 is equal to 5.25 millisecond. So the response time, process 0 equal to 0 millisecond minus by 0 is equal to 0 millisecond. And process 1, 5 millisecond minus by 1 is equal to 4 millisecond. Process 2, 40 millisecond minus by 2 is equal to 12 millisecond. Process 3, 8 millisecond minus by 3 is equal to 5 millisecond. So we move to question C. Thank you. So question C is round robin scheduling algorithm. So first of all, we move to Gantt chart. So process 0 start at 0 and end at 3 millisecond. Process 1 start at 3 millisecond and at 6 millisecond. Process 2 start at 6 millisecond and end at 9 millisecond. Followed by process 3 start at 9 millisecond and end at 12 millisecond. So we start again. Process 0 start at 12 millisecond and end at 14 millisecond. Process 2 process 1 start at 14 millisecond and at 17 millisecond. And process 3 start at 17 millisecond and at 20 millisecond. And finally, process 2 start at 20 millisecond and end at 22 millisecond. For the average turnaround, as usual, we have to subtract and divide all the answers. So process 0 is 14 millisecond minus by 0 is equal to 14 millisecond. And process 1, 6 millisecond minus by 1 is equal to 5 millisecond. Process 2, 22 millisecond minus by 2 is equal to 20 millisecond. And process 3, 20 millisecond minus by 2 is equal to 17 millisecond. So after divide all, total all the answer divided by 4 is equal to 40 millisecond. Followed by waiting time, the answer is 8.5 milliseconds. So as usual, process 0, 40 minus by 5 is equal to 9. And process 1, 5 millisecond minus by 3 is equal to 2 millisecond. Process 2, 20 millisecond minus by 8 is equal to 12 millisecond. And process 3, 17 millisecond minus by 6 is equal to 6 millisecond, 11 millisecond. So after total all the answer divided by 4 is actually equal to 8.5 millisecond. And finally, we move to response time. Process 0 is equal to 0 minus 0 is equal to 0 milliseconds. And process 1, 3 minus 1 is equal to 12 millisecond, 2 millisecond. Process 2, 6 minus 2 is equal to 4 millisecond. And finally, process 3, 9 minus 2 is equal to 6 millisecond. That's all from me. I'll give to Shalini. Thank you.
The next one, priority for scheduling algorithm. Priority scheduling algorithm table to show the process with their burst time, arrival time, and priority. Process P0, burst time is P0 for 5, arrival time 0, priority for burst P0 is 1, P1 3 for burst time, arrival time 1, and then priority time 2, P2 the burst time 8, arrival time 2, priority time 1, P3 the burst time 6, arrival time 3, priority time 3. Based on the table 2, solve the problem for question 2D referring table 2. This is the Gantt chart for table 2. How was the process 0 to 25? First, the P0 is 0, P1 1, P2 2, and then P3. The Gantt chart 0 until 25. P0 arrived 5 milliseconds, 30, P2 arrived 30 milliseconds, 60, P1 is arrived 60 milliseconds, P5 22 milliseconds. Average turnaround for time is TAT minus ET minus average time. P0 equals to 5 milliseconds minus 0 equals to 5 milliseconds. P1 60 milliseconds minus 1 equals to 50 milliseconds. P2 30 milliseconds minus 2 equals to 11 milliseconds. P3 equals to 22 milliseconds minus 3 equals to 90 milliseconds. The total average is calculate 5 plus 15 plus 11 plus 19. Divide by 4, get 11.5 milliseconds. This is the for priority scheduling algorithm. The next two, average waiting time. WT minus TAT minus burst time EQT. P0 equals to 5 milliseconds minus 5, get 0 milliseconds. P1 equals to 50 milliseconds minus 3, get 12 milliseconds. P2 equals to 11 milliseconds minus 8, equals to 3 milliseconds. P3 equals to 19 milliseconds minus 6, get 30 milliseconds. Total all calculate 0 plus 12 plus 3 plus 30, the get divide by 4, 7 milliseconds. The response time start a Gantt chart arrival minus arrival time. P0 equals to 0 milliseconds minus 0, get 0. P1 equals to 30 milliseconds minus 1 equals to 12 milliseconds. P2 5 milliseconds minus 2 equals to 3 milliseconds. P3 60 milliseconds minus 3 equals to get 30 milliseconds. That's all for the algorithm priority for security for table 2. The question 3, by referring to figure 2, discuss the process involved for the deadlock to happen. This is the for process deadlock, how the deadlock is happen. Process 1 go to process D is going to request for resource 1, and then the resource 1 allocate for process 2 C. The process C requests for T resource 2, and then the T goes to D allocated. This is the process for figure 2 deadlock. How was the process happen first and until last? This is the process. For a process is waiting for the resources held by the second process, which is waiting for the resource held by third process and so on. Feel the last process waiting for resource held by the first process. This form a circular chain. For example, process 1 is allocated resource 2 and it is requesting resource 1. Similarly, process 2 is allocated resource and it is requesting resource 2. This forms a circular wait loop. This is an how will happen the process first until last. That's all from me. Thank you.